Hi everyone, welcome to episode 3 of the Signal and Noise podcast on large language models. Today we'll be discussing sovereign mode personas, how to build custom systems with superprompts. We'll be learning how to reliably turn a general LLM into a specific, powerful and repeatable expert. Do this in 4 sections: the mask and the mind, why personas work at all, constraint is power, why limits make models smarter. When the role becomes reality, we'll look a little bit at emerging behaviour, and from power to responsibility, building boring AI systems. Part 1. The mask and the mind. The model is always playing a role, and if you don't choose the role, one will be chosen for you. The default persona is a helpful sycophant. The system prompt will often define the role. For example, helpful assistant, teacher, expert, librarian. But why do personas feel so powerful? So the model is not reasoning as itself. Instead, it simulates a role with values, incentives, and a worldview. Language models are identity following engines. Persona shaping gives us more control over our results. So what does our model notice? What does our model prioritize? What does it consider to be correct? And how confident is the model allowed to be? Persona shifts the probability of next token prediction. We go from the probability of a sycophantic token prediction to a probability of an expert token prediction, and these are not the same. A sycophant will prioritize agreeableness over truth. It will hallucinate a response to please you over avoiding conflict, and it will imply a persona based on the tone of your input. So we're concerned with the filter of identity. What does our model care about? A poet notices cadence. An engineer notices structural stability. A CEO prioritizes brevity. An academic prioritizes nuance. A marketing copywriter considers hyperbole to be correct, but a compliance officer considers it a failure. Humility tells our model when to admit that it doesn't know. Personality is adjectives. Personality, tone, voice, style. Speak like a pirate, be witty. This results in surface level texture variance and little influence over deep logic or reasoning. However, a persona can be defined in terms of 4 dimensions: the identity, the motivation, the domain knowledge, and the process. The who, the why, the what, and the how. This gives us significantly more control over shaping what we want our large language model to do, and how we want it to do it, why we want it to be done, and to a certain extent, who is doing it. Its objectives and constraints. A persona is a cognitive frame, constraints and authority. For example, a senior Python architect who strictly adheres to PEP 8 standards with a focus on low latency system. We've now got a fundamental change in logic, which leads to a fundamental change in token prediction. So you can tell the difference between the rather simplistic characters I've been developing previously and the more complicated character image that is now revealed itself in the bottom right hand side of the corner. When you define a persona, you implicitly define its antipose persona as well. This is the Waluigi effect. So care must be taken to define the positives as well as the negatives. Negations are weak. Naming failure can often induce it. Specify the good behavior and default. Do not be deceptive becomes be transparent. State assumptions and sources, and say, I don't know, when unsure. Models don't optimize for avoidance, they optimize for what to do next. Negatives remove options without giving the model a target to aim for. A prohibition without a target creates ambiguity. Ambiguity increases variance, and variance increases hallucinations. We want to eliminate or at least minimize hallucinations as much as possible. Hallucinations are the enemy of large language models after all. So drift is not a model flaw, it's a missing constraint problem. Drift occurs when the user reframes a task, the context changes, the model fills in missing roles, or the model reverts to default assistant mode. A model that behaves well after 10 turns, 10 loops of conversation, is one that knows what to do when the information runs out. So a persona is the mask the model wears. It changes knowledge boundaries, it affects decision heuristics, it influences risk tolerance, and it impacts explanation depth. Part 2. Constraint is power. We often think that constraints restrict capability, but in reality they focus power and concentrate intelligence. Freedom increases creativity. Constraints increase reliability. We don't want our tools to be too creative. We want reliable, repeatable, auditable, testable, verifiable systems. Language models reason by probability, not logic. It's important to remember that. Constraining the model collapses the probability space to only the parts we are interested in, compared to the entire corpus of written language if it's not constrained. A collapsed probability space leads to fewer potential paths, less ambiguity, less contradiction. Generally, a stronger signal amongst the semantic noise. We discussed earlier that central collapse as a problem. However, when you want a reliable and repeated system, you want the model to collapse to the center that you define. The default model is too general to be useful for specialist tasks. It's a good general use tool, but it's overly helpful, broadly knowledgeable but not specifically knowledgeable, politely uncertain, and optimized for safety over usefulness. This is fine as a gateway. It's a good default, but it's a terrible specialist. Specialism is not added, it's carved out. As humans, we have to add knowledge to become specialists. LLMs need the information removed from their defaults. They need to get rid of the noise so they can focus on the signal, the useful information within their training dataset. By creating a persona, we change what the model pays attention to. We can narrow the scope, we can raise the standards, we can define authority, and we can limit the output modes. The 5 constraint layers, all of which are necessary: scope, knowledge, reasoning, expression, and refusal. What topics are allowed? What sources are valid? How conclusions are achieved? How answers are written? And when the model must stop. Missing one layer weakens the whole persona. For example, you're an expert in UK accessibility policy. UK accessibility policy is the scope. Answer only using WCAG 2.1 guidelines. This defines our knowledge boundary. Reasoning. First, cite the regulation. Second, explain the violation. Third, propose a fix. Rate your confidence in your explanation out of 10. This is our reasoning stack. Use professional and compliance-focused tone. Do not apply a conversational filter. We're defining our positives and our negatives in our expression. And finally, the refusal. If these ask for evidence for anywhere other than the UK, then state that this is out of scope. This prevents the model from inadvertently giving information or answers that it thinks are right or are right within its scope, but are wrong elsewhere. Scope constraints. What topics are allowed? Scope constraints protect responses from topic creep, overgeneralization, and accidental advice. So, in our example, only give advice on UK transport-related accessibility policy. The scope defines the relevance, and the relevance defines the usefulness. Knowledge constraints. What sources can be considered? Knowledge constraints allow specific and useful responses. Unconstrained knowledge can lead to general advice. We don't want general advice. Edge cases and specific operating processes risk being ignored. So institutional knowledge, very specific but unintuitive answers that we know are correct. The knowledge informs the accuracy informs the usefulness. Reasoning constraints, how the model thinks. These allow for complex and more robust processes than simple next token prediction. Ultimately, large language models do resolve down to next token prediction, but we can add intermediate steps that improve that at the end. Opportunity to add multiple threads, red teams, model variations, and model validations. What assumptions can be made and what risks are acceptable. Reasoning constraints shape thinking, not tone. And refusal as a feature. Even the monarch needs to know when to stop. The model needs to know when to say, I don't know, and needs to know when to seek clarification, and it needs to know when to refuse entirely. If the model never says no, it's not constrained. If it always says no, it's not useful. So our constraints prevent role collapse. Without constraints, the model outputs will drift, they'll blur, and they'll degrade over time. With constraints, the model outputs are persistent, stable, and predictable. And this is what we're aiming for when it comes to production-ready AI systems. It's also important to remember sovereign mode is not unlimited power. Omniscience becomes clear authority. Unlimited creativity becomes defined boundaries, and answering everything becomes predictable excellence. Power comes from precision, not from permission. The sovereign mode is not a gimmick. It's a high authority specialist designed for repeatable excellence. It can be trusted in production situations because it has clear roles, defined standards, specific boundaries, default answers, and fallback positions. Part 3. When the role becomes reality. What happens when the persona becomes the center of gravity? Your assistant will answer questions. Your persona will evaluate inputs, reject bad premises, and challenge assumptions. The authority changes the direction of thought from how can I help to is this correct? The persona helps adopt standards, it helps maintain coherence, and it helps resisting reframes. The persona acts as an anchor, continually pulling the model back to center, our center, the center that we've defined. So this can feel less helpful, but is much more useful for production grade systems. It can push back on vague requests, it can refuse misaligned goals, it can demand clarification. And as we mentioned previously, refusal is a feature, not a bug. And refusal can happen in multiple modes. So you can have a silent refusal for low risk situations where the model may steer the topic. You can have a soft refusal for medium risk situations. I can't do this, but how about this? And then a hard refusal for high risk situations. This violates safety guidelines. Stop. A good AI system teaches its users how to trust it. Sovereign mode personas are not silver bullets, however. Anyone who implements them needs to be aware of these limitations. You're not adding intelligence, you're removing distractions. You're not unlocking truth, you're structuring doubt. You're not solving hallucinations, you're reducing them. Part 4. From power to responsibility. The 4 rules of AI products. The product predicts the pattern, not the truth. Prompts are programs, structures be vibes. Memory, grounding, and retrieval lead to reliability. Constraints carve specialism and personas prevent drift. The model itself is not the product. The product is the scaffolding we wrap around the model. Most AI products fail for human reasons, not technical ones. The model does exactly what it is allowed to do. We just told it poorly what it was allowed to do. The human infers more authority than was granted. The fluency is mistaken for certainty, but this is no longer a model issue. This is an institutional psychology issue. When the wrong man uses the right means work in the wrong way. We need to bear in mind everything that we've learned so far when we design the systems that scaffold our large language model and allow us to do the tasks that we are really looking for and aiming for. Here are some failure modes. The AI said it was fine. Why? That's not an excuse. It sounded so confident. Again, it's not an excuse. And it didn't refuse, so I assumed it was allowed. The AI said it was fine. That's a human error. We haven't built in to our AI systems enough accountability and enough traceability and enough trust that we can do that. The AI said it was fine. Why are we trusting the AI? How can we program our prompt so that the AI doesn't generate blind trust? It sounded so confident. The same issue. We need to move away from thinking about these things as being fluent equals confidence and presenting the information that we're using to make our decisions. It didn't refuse, so I assumed it was allowed. Well, why didn't we engineer a guardrail into it? Authority transfer is a real risk vector when people treat it like an expert witness rather than a program. A user may see one thing and assume another. Confidence is not confidence, structure is not rigor, and citations is not endorsement. The model does not claim authority, the user donates it. The goal is not complete trust, it is calibrated trust. Where low trust is required, drafting, ideation, rewording. Where medium trust is required, analysis, citations, and review. And high trust, where execution only after human sign-off. A good AI system teaches its users how to trust it. Failure is inevitable, so anticipate failure and design their shape. Smooth, plausible fabrications become I don't have enough information to answer that. Silent scope expansion becomes That is beyond my defined scope. Overconfident synthesis. The sources do not support a confident conclusion. The best systems are not the ones that never fail, but the ones that fail loudly, clearly, and early. Saying no increases long-term value. Every refusal is a diagnostic signal. Good systems, refusals are logged, patterns are analyzed, knowledge evolves, system design iterates. The refusal goes to what data is missing, is the scope unclear, and what are the user assumptions. Refusal is not a dead end, it's feedback. The skill ceiling has shifted from prompt craft to system stewardship. Beginners focus on clever prompts, professionals focus on retrieval quality, constraint clarity, review loops, ownership. The most valuable people in AI-enabled teams are not the ones who get impressive answers, but the ones who prevent bad ones. This is the shift from prompt wizard to AI systems steward. So what does production grade actually mean? Can the system explain where each claim came from? Can it refuse gracefully? Can its behavior be reproduced tomorrow? Can a mistake be audited after the fact? And if not, it's a demo, not a product. Production grade isn't powerful, it's powerfully boring. So how do we think about AI systems going forward? We move from what can this model do to what is it allowed to say? What is it allowed to know? When must it stop? And who is accountable for the output? We're moving from curiosity to capability. The future of AI systems is not louder models or smarter prompts, it's quiet systems that know their limits. We have to remember models are probabilistic and not knowledgeable. We need to design for that. System design can induce reliability in models, more reliability in models, more specific reliability in models, and constraints can create trust in the models. With all that said, people must remain accountable for the model's output. Again, production grade isn't powerful, it's powerfully boring.